Good morning. Today we are going over packet number 11. It is due on May 6th. Our first page says, Janet's family was having a reunion at the picnic grounds. She bought 10 pounds of hamburger and could make 4 hamburgers per pound. Her family ate 34 hamburgers. How many pounds of hamburger meat did she have left? There are mathy ways to do this, but a lot of times with the word problems, I just go straight to my bar models, just so we can see how we do that. So for a bar model, I would call this all of the pounds. She bought 10 pounds of hamburger, so I'm gonna break it up into 10 sections. Each one is a pound of hamburger. Now each pound makes how many hamburgers? It makes 4 hamburgers. So each one of these has 4 hamburgers to it. Her family ate 34 hamburgers, so I need to figure out where that 34 hamburgers falls. Adding up by 4s, I'm going to have to break up because 4 doesn't evenly go into 34. So I'm going to have to break up a pound and figure out how much of that pound went to the hamburgers they ate and how much of that pound is what's left over. Okay, so figure that out to see how many pounds of hamburger were left over. Not how many hamburgers, but how many pounds of hamburgers. Our second page says, a train is going from Lilywood to Hermantown, along the way stopping at Green Lake and Highland Hills. At Lilywood, there are 108 passengers on the train. So our train is going from Lilywood to Hermantown, stopping at Green Lake and Highland Hills. So we start with 108 passengers. Several get off at Green Lake. I don't know how many to subtract there. That is what we're going to find. But I do know that 26 board the train there. Then it travels on to Highland Hills, and we have 24 get off at Highland Hills, and we have 3 get on, and we end at Hermantown with 71 passengers. So, to figure this out, you can work backwards. If we had 71, opposite operations. If we're going to work backwards, we're going to do the opposite. So we would add 24 and subtract 3. Subtract 26, and if we take that answer and subtract it from 108, we'll figure out how many actually got off the train at Green Lake. Our next page is our 5-card challenge. Some of us have discovered, this 5-card challenge has an ace in it. So remember that ace is only can be a 1 when we do 5-card challenge. It can't also be an 11 if we decide, like if we were playing blackjack. For the 5-card challenge, ace is always only 1. But you could have something like, let's say, 6 minus 3 is 3. You can multiply that 3 by 1. And it's a whole different equation. You still get the same answer, because 3 times 1 is 3, 6 minus 3 is 3. But you can really rack up how many points you get. I have some people actually challenging themselves to see how many points they can get for this 5-card challenge. I've had people ask me, what is the highest number of people I've gotten? In 6th grade, on a 5-card challenge, I don't know exactly which one, but on a 5-card challenge, the highest amount was 150 points. all together, 6th, 7th, and 8th grade, the highest amount was over 1,000 points. Because they're using their aces wisely. They're helping to use those to rack up points. They're really thinking it through. So challenge yourself. See how many points you can get for the 5-card challenge. You only need to get 12 to get credit for it, but see if you can get more. Our next page is our pattern page. 6th grade, or Math 6 needs to complete the table up to the 6th figure. So we can fill in the first 4 figures by what we see. There is 1 green and 8 blue, so there are 9 total blocks in that first figure. Our second figure has 5 green with 16 blue for 21 blocks. The third figure has 9 green with 24 blue for 33 total blocks. And our fourth figure has 13 green with 32 blue for a total of 45 total blocks. So now we need to look for those patterns. How are we increasing from 1 to 5 to 9 to 13? We're adding by the same number. Figure it out and continue that pattern. For our blues, I look at these blues and I notice they're all multiples of 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4. Figure out what the next 2 will be. Whether or not you can figure out the pattern for the total blocks, we know we can add the green and the blue to get the total blocks. And so complete those patterns. Our next page is our area page. Remember that full figure is the entire shape. So our full figure is this whole shape. We were just learning in math class the area of that rectangle is length times width, length times width. That will be your full area figure. Then you need to find the shaded area. So we need to find the area of the white and take it away from that full figure so we're left with just the shaded. But that white is a goofy shape. So you're going to want to break it into a rectangle and a square. Making note that this length is 4 altogether. So when we are looking at this little square right here, it's not a full 4. 2 of the centimeters are over here. So you need to figure out what this length is to find the area of this shape. Easy to know our length and the width of the rectangle to find that area, but you have to do some thinking to find that length for the square. Our next page is the one that we need to fill some stuff in. Sometimes I remember to copy over Mr. Schultz's number. Sometimes I forget. I did not copy it over for this one, so you can write down some numbers. So we've got length times width times height for our rectangular prism formula for the volume. Our length, you can put 25. Width, you can put 8. Remember, we take that full volume, 300 equals length times width times height. To get that height by itself, you do opposite operations. So you want to move that 25 over to the other side, move the 8 over to the other side, using opposite operations. If they are multiplying, the opposite is going to be dividing. For our cube, it's length times width times height, but remember that cube is made up of squares. So all 3 of these numbers need to be the same number. What number do you multiply together those 3 times to get 0.125? So you will be working with a decimal. For our triangular prism, we have 1/2 of the length times the width times the height. Our base length is 0.5, width is 1. For our pyramid, it is 1/3, length times width times height. Our length is 20 and the height is 3. For our cylinder, it is pi r squared times height, and our height is 7. For the cone, it's pi r squared times the height divided by 3, and our height again is 7. And for the sphere, it is 4/3 times pi r cubed. Remember that Math 6 only has to do 2 of them, but you can challenge yourself to do more. So you only have to do 2, but it's always good to challenge ourselves. If you need to write any more of this down, you can always look at the video or ask a friend how to fill in those. Let's look at our last page. Our last page, they are giving us the graph that tells us percentages of doing a triathlon. So there was swimming, biking, and running. Our question is, who spent the highest percentage of time biking, and who spent the lowest percentage of time biking? So we want to look at the biking, which is the dark blue. Write the highest percentage and the lowest percentage. Give me their names. And that is it for our packet number 11. Again, it is due next week, Tuesday. Turn it in by Friday, and you can make corrections on it. I hope if you are watching this at home, if you still have any questions, you come and ask me. I hope to see you soon. Bye.